This is the information for Unit 2, going over construction math and the application of math used in construction. And what we will uh, be covering in this section, we should be converting between proper fractions and mixed numbers. We will add, subtract, multiply, and divide decimal fractions, calculate dimensions, calculate areas and volumes of objects, and related math to construction problems. These are the terms that you need to review and go through the glossary and these terms so you can understand them clearly. But these all are math issues and terms that you need to know. If you have taken the basic technical math, this should be no problem. And a fraction is something that's less than a whole. In this diagram, we see there are 16 blocks, but have been separated. So the top portion, we call that the numerator, and the bottom portion is the denominator. The difference is the numerator tells you what part of the whole it is, and the bottom, the denominator, tells you everything, the whole. So again, we separated this block from 16 blocks to 7 blocks. So that portion of it is 7 of a whole, which in the whole is 16. So it's 7/16. So if I put them all together, it will be one whole. As we, matter of fact, let me just point it out. We see right there. This is the whole. 16 over 16 means it is 1. Anything less than 16 is a fraction of a whole. In this case, it is 7/16 because there's 7 blocks. The numerator is typically less than the denominator. When the numerator is the same as the denominator, it is a whole, it's considered 1. But here's something to keep in mind. We never express it 16 over 16 or 4 over 4 or 10 over 10, 12 over 12. We do not ever express it. That would be considered improper fraction. And so we express it whatever it is at that point. So when we have a numerator greater than the denominator, it's improper fraction, and we will simplify it. So in other words, we look at this as 5/4 is the same thing as 1 and 1/4. 1 and 1/4. The reason why is that 4 over 4 is 1, and what is left over is 1/4. The same thing with 19/16. And so that will be 1 and 3/16 because 16 go into 19 one time and there's 3 left over. So 19/16. So whole numbers can be changed into fractions very simply. In other words, there's an example, change the whole number 6 into 4s. The certainly you can do that, and you can show that as a number. And here's how you can do it. Whole numbers can be changed into fractions. For example, this here, 6 over 1 is 6. Then we could take 4 by 4. So if we multiply it across, it will be 24 over 4. So we change it into 4s. And again, it's an improper fraction. So if you simplify it, the answer would be 6. Because 4 going to 24 6 times. So mixed numbers can be changed into improper fractions. Again, uh, here it says convert 3 and 5/8 into an improper fraction. And how we would do that is just look at how we can change it this way. Uh, it would be the same thing as 29 over 8. And this is how we do it. We could multiply 8 times 3 and add 5 to it. 8 times 3 is 24, plus 5 is 29. So it's not really that hard. We can go through the problems like this here. Of course, I see it again. You multiply the um, denominator by the whole number, then you add the numerator to it. That's basically the quick way to do it. It says improper fractions can be reduced to a whole or mixed number, and we can go by looking at this 17/4 into the lowest proper fraction. And we do the same thing. We would divide 4 into 17, which is 4, and that would be 16th, and what you have left is 1/4. So again, it's not that difficult. So you can look at this. We divide 4 into 17, and what is left over is a remainder of 1. So it's 1/4. So reducing fractions by dividing the numerator by the denominator by the same number. Uh, Again, we look at 6/8. We want to reduce it as low as possible. And we can look for a number that can go into those numbers evenly. Um, well, 2 can go into 6 3 times, and 2 can go into 8 4 times. So it looks like it's 3/8. 3/4, and it can take it any further than that. So let me just show you. Um, we got 6/8 equals, and like I said, we look for a number that one number that can go into both numbers an even number of times, and 2 is that number for 6/8. So fractions can be changed to higher terms by multiplying the numerator by the denominator by the same number. And again, we could change 5/8 into a higher terms, 5/8. The question is, can you? Or you can make it a 10/16, or you can keep it to 30 seconds, 20, 30 seconds. So those are other ways you can do it. In other words, if you want to take it into higher terms, of course, to simplify it, it is 5/8. But 5/8 is equivalent to a 10/16 or 20, 30 seconds. Adding fractions. Uh, when you're adding fractions, you just can't just add them across. It must have a common denominator, which means that we have to find a number that we can use so we can add the fractions together, because you cannot add fractions if the denominator is different. So in other words, if you have a 1/4 plus uh, 3/16, you cannot add it together. We would have to change it, one of the numbers, to make it work. So in this case here, so what's the simplest common denominator? We can look at this. For example, we got 5/16, 3/8, and 11/32. And can we reduce any of these numbers? Don't look like we can reduce it. So we're going to have to step it up. So look like all of them is equivalent to 32. So if I change 5/16 to a 32 or 30 seconds, that would be 10/32. For the 3/8, that would go into 32 even number of times. So that would be 4 times. And so I multiply 4 times 3 is 12. So it'll be 12, 30 seconds. And the very last one is already 30 seconds. There's nothing I need to do with that. So as long as I can have a common denominator, I can add fractions together. So here, like I just did the first one, we did the second one, we add them together when it's 30 seconds. And we see it's 33, 30 seconds. And so to simplify it, it'd be 1 inch and 1/30 seconds. Alrighty, I'm going to take some time, go through the practice problems in the textbooks before we go any further. These are your answers. Try to go through the practice before looking at this to make sure you got it. Subtracting fractions. All denominators must be the same, just like when you're adding. So again, you need to find the least common denominator. And then you subtract the numerators to retain the common denominator. Convert the mixed numbers. So in other words, convert to a mixed number. So the best way to do it is you will change it to fit what you need. So look at what we have here. Least common denominator, we cannot reduce 3/4, but we certainly can take it to a higher number, 16. So 4 go into 16 4 times. So I multiply 4 times 3, which is 12. And so I could subtract it at that point. I subtract the numerators. And you can see the answer, 7/16. Alrighty, let's go through and let's take some time to go through your practice problems. And we're going to go through it in class on next week. So while you go through this, um, take your time. And here's the answers so you can be able to check it. Multiplying fractions. First, you need to change all mixed numbers to improper fractions. So that would be the very first thing. So if you got like 1 and 5/8, you would have to change it to a improper fraction. Multiply all the numerators, multiply all the denominators, reduce to the lowest terms. Again, we see 3 and 1/8. So to take it into an improper fraction, we will multiply 8 times 3, which is 24. We add the numerator, which is 1, will make us that number 25/8. So now we can multiply. So now we have 1/2 times 25/8 times 4/1. So we multiply the numerators across, multiply the denominators across. And it comes to 116ths. Now we need to reduce it to the lowest term. To do that, we divide 16 into 100. And you see the answer comes out to 6 1/4. Alrighty, let's take 15 minutes to go over the materials so we can go to the next step. And before you go to the next slide, um, to get the answers, just take a look. Dividing fractions. And when you divide, it's a little bit different. You need to the first thing you would do, you need to certainly change it into improper fractions. Then you convert, in other words, what they call the reciprocal. The reciprocal. Invert, turn upside down, or the reciprocal. The divisor to multiplier. And you see. So in other words, this problem here, you got 5 1/4 divided by 1 1/2. So the very first thing we need to put it in proper. So that'd be 21/4 divided by 3 halves. And now we're going to flip the divisor. And so, which means that we're going to flip this. Instead of being 3/2, it would be 2/3. Then you change the sign. So once we invert the divisor, we would multiply at that point. We change it to sign. So now we can multiply 21 by 2. We give us 42. We multiply 4 times 3 is 12. Now we can reduce it to its common lowest form. All right, let's take a 15-minute break, go through the materials again. And as you go through your reading materials, just take your time, go through it. And here's your answers just to verify. Now, fractions is not really that hard. Dealing with decimals is, in my opinion, is easier. But I guess it can be more accurate too. But as long as you got a calculator, it doesn't matter. So again, a denominator in a decimal is 10 or multiple of tens. So the denominator. So to omit the denominator and insert a decimal point in a numerator. So again, let's look at this. 3/10 is written as 0.3. We could take any fraction and turn it into a decimal by dividing the denominator into the numerator. If we did that, we'll always come with that decimal. So again, we look at this. Adding, subtracting decimals. Just like adding any number together, you just have to keep your numbers in place based on your decimal point. It has to be aligned up vertically. If you don't do that, you will be off. You will have a wrong answer. So your decimal point must be aligned vertically to add your numbers or subtract your numbers. So if you look at this, this is out of place. If I try to add it, it will come up wrong. So I have to bring this point right underneath this. So I start here, run my numbers down, and keep going. Everything has to be lined up correctly. And this will be the proper way to line it up. Now I can add it to come up with the right answer. Subtracting is basically the same thing. I must line up my decimal. got another practice session as you go through your book and be able to go through these problems of adding, subtracting decimals. These are your answers. So go through it first just to verify. Multiplying decimals. Keep the same thing in mind. Um, you don't have to line anything up when you're multiplying, but what you do need to do is make sure you count your places. Count the places, the decimal places, and that's tells you where to set your decimal in your answer. So that's what I mean by counting your places. Everything to the right of your decimal, count it. How many digits? This is one digit here, two digits, three digits. So when you come up with your answer, you will count from the very far right over to your left those number of digits so you know where to place your decimal point. So the answer came out to be 9375, and I got three digits, so I'm starting here. So that's 1, 2, 3. Where you start out, it's not a place. That's where you're starting at. So you count each place you jump. So that's 1, 2, 3. Okay, we can go through and um, go through the problems, multiply decimals, and your answers. You can stop the tape and get your answers. Dividing decimals. Now, dividing, counting the places is another, you have to count them again. So you divide like you divide any number. So when you're dividing it, you do not look at um, the decimal places. You only consider your decimals places only after you come up with your answer. And here's a way to show you. So this is 6.5 divided into um, 26. Now, like I say, you don't consider the point, you just pretend it's not there. So basically, you're looking at dividing 65 into 26. Of course, we know that it doesn't go into it. It would be less than. So in other words, it would be less than 1. So what we do, we take the decimal point and start it right there. That's where our number starts. Okay? And then, since it doesn't go into this, the first number will be, we actually put a 0 here, put a decimal right there. We put a 0 here. So 65 can go into 260. Here, let me just draw on this so you can see it. Let me put a color here. It's not working. Try this. And go to black. Well, for whatever reason, oh, there we go. I know why. So we put a 0 right there. So 65 will go into 260. And let me see, that is 130. So it looked like it would go into it. Um, so we put a decimal right. I'm sorry. Let me erase that. Okay. Let me go back to this. So we put a decimal right there. So we start our number here. So it will go into 4 times, I believe. This is this top of my head. So the answer would be 0.4. Let's find out if am I right. Oh, I guess I am. So um, now we move the decimal places over based on that number. So they show 4, um, but that's not correct. Uh, Again, I don't know why they show you that way because we know that. Oh, let me take that back. I'm sorry. I don't know what I'm looking at. 6.5 does go into 26, and it is 4 times. My fault, but you still put the decimal point there. Um, I just put it in the wrong place. I actually overthinking myself. There you go. And we can't put a 0 here. Alrighty. Okay, here's another problem. 4 point. Like I say, you need to count the decimal places over, so you can certainly know where to start at. So in this case here, we would add. So there's like 412 going to move your decimal places over 2 extra places, 1, 2. And that's what we did here. That was 36.5032. We move it over 2 places, and that's where we start our number at. All right, let's take our 15-minute break to go through the problems. Stop your video and continue to go through. Here's your answers. Dimensions are made up of whole numbers and fractions. And so when we're looking at dimensions, when we see um, 1 mark, meaning feet, when you see 2 of these um, dimension marks, it means inches. We keep it lined up. In other words, where you see the dash, we line up the feet in inches, and we will um, feet lined up under each other, inches lined up under each other, and we add them or subtract them to get the correct answer. Now, decimal foot values. There's a chart that gives you that. So again, when you're looking at this, remember to get a decimal, you would divide the denominator into the numerator. So if I did that for 1/16, it would come to 0.0625. And so that giving you um, that number. To go into foot values, now we know a foot is greater than that. So in other words, we have to find out how many sixteenths in a foot. So we know in 1 inch, it is 16 sixteenths, and we know there's 12 inches, so we need to multiply 12 times 16 and then divide it into that number. So that's how we able to get that number. So using a chart like this will help you. If you got a calculator, it makes your job faster and easier. Area is the space, base like wall space, floor space, ceiling space. In other words, it's always the length times the width. That is space. So again, area of a floor or walls or ceiling of a yard, or let's say the space around a perimeter of a building, uh, the space. So in this case here, we see that there is a 12 by 10 room. And so to find out what the space is in square feet, we will multiply the length times the width to give us square feet. It works the same way. It says for lengths given in feet and inches, convert to a decimal so that the answer comes up a lot easier, which is would speed up the process for you. Because if you have to figure it the other way around, you have to put it into one form or another. So just changing to a decimal would make it a lot easier. Triangular area. And the formula basically, let's look at a couple things first. We have the base of the triangle, then we have the height of it. Okay, and base it says divide the sum by 2. Multiply the base times the height, and divide by 2. So if we have 24 and the height is 5, so we multiply that and divide it by 2 will give us the answer. So again, 60 square feet. When dealing with circles, which we will deal with time to time, a couple of things you need to know, the terms of a circle. The circumference is the distance completely around the circle. The diameter is the length going across the circle, but is bisecting or going through the center of the circle, the exact center of the circle. So diameter is going through the center of the circle, going from end to end. The radius is taking that center and going to the end of the circle. The radius is the same no matter where you take it in a circle. A circle is, when it's a complete circle, an exact circle, the radius is the distance from the center, which is half of the diameter. Pi is a term we use and working with circles or working with an arc or anything that is that's part of a circle. So pi is used to determine the circumference, the area, or the volume of a circle or cylinder. In other words, volume of a cylinder. So in other words, we want to figure out the volume of a circle. We use that and use that information to determine the volume of a cylinder. So pi is the ratio of the circumference to the diameter. And it's an unending number, but we just use it as 3.416, 3.1416. So circular components. And here goes to more than you probably ever want to know, but these are the formulas that you would use and some of the terms that you will use, like the radius, going from the center of a circle. The radius goes from the center to the outside of the circle. And that radius is the same no matter where you take it in that circle because it always starts at the center and goes to the outside edge. If it's anything different, the radius, it is not a circle. It's an oval, it's something else, it's something besides a circle. So when we're looking at parts of a circle, taking a segment of it, we call that the chord, the distance. Um, the circumference of a circle is the distance starting at one point and going around the circle and ending at that same point. So the formula for a circumference is taking pi times its diameter. Times its diameter. So if you know what the diameter is, multiply times pi, and you will know exactly the distance around that circle. Let's see, anything else? Tangent. Tangent's basically if using um, mm, let's say trigonometry, we use tangents all the time. And tangent is basically taking a is that part of the circle and looking at how it's touching that circle at a certain point, and and based on that angle, the angle. So, and is the angle of a curve from a straight line. So, circumference is diameter times pi. And so, like I said, if you knew or know what um, the radius or the diameter, either one, it would give you the answer. The radius would be 2 times the radius or pi times diameter. So pi times 2 times the radius or pi times the diameter. Both of those would give you exactly the same answer. So in this case here, it's to find the circumference of a circle that is 6 feet 6 inches in diameter. So that's a pretty large space. So what we do, just take that, we convert those inches into a decimal, and how we know that, we devise basically we just take 12 and divide it into 6, and we will have zero point 0.5. So if we multiply it out, it's 20 feet and 40.42 feet. 20.42 feet. So individual portions along the circumference of a circle are called arcs. In other words, arc is a partial circle. A partial circle. We use arcs all the time when you're making bends in conduit. If you are have a curve in a wall, basically it's an arc. So determine the length of an arc that has a radius of 4 feet 3 inches and an arc of 90 degrees. First, determine the circumference. Next, you determine the portion of the arc. The portion that you're looking, like I say, it's only a portion of that curve. Then divide the circumference by the portion of that arc. That will give you the answer. So let's take a look at that. So we have um, a circumference. Uh, basically, we have not the circumference, but we have a diameter of 4.25, and we multiply it times 2. We come up with 26, and the portion of the arc is 90 degrees, and we will, and we know there's 360 degrees in a circle. So we divide it into it, and we see that the answer is zero point 0.5 or 1/4, 1/4. So circumference divided by portion. So now um, it comes to, we take the 26.7 feet, and we know what the portion of it now, of that arc, is 25% of that full circumference. And so the distance of that arc is 6 feet and 8 inches, or better yet, 6.68 feet. And it just rounded off to the closest number, so which is 8 inches. Area of a circle. The area of a circle is the space within a circle. And the space within a circle is pi times the radius square. Pi times radius square. So once we're looking at a circle, if we know what the radius is, or better yet, if we know what the diameter is, we can take half of the diameter, then we would square the radius. So determine the area of a patio that has a diameter of 30. So first we have to do is that since we know that the radius is half of the diameter, we have to change it to 15 feet, and we have to square it at that point. So basically it's pi, which is 3.14 times 225. And that would give us the area of that circle of 706 feet, 0.86. So 706.86 feet. Volume measurements, that's why I was saying a cylinder. So a cylinder, we're measuring volume at that point, but you need to know what the area of that cylinder first, of that circle. So volume is a cubic measurement, determined by multiplying the area by the depth. The depth. The depth will be the length of that cylinder. So here's an example. He said, find the volume of concrete for a 4-inch thick patio that has an area of 706.86 square feet. Okay, so in other words, we got the area, and that patio is 4 inches thick, the concrete that you need to pour. So now you're going to determine how much concrete you're going to need. So we're going to convert inches to decimals, feet, and multiply the area by the depth, which is 4 inches. So this is how they did it. It takes 4 divided by 12, which equals 0.333. Actually, it's an unending number. It keep on going, but you can take it 3 places. You will come up close enough. So the next thing you're going to do is take that 706.86 square feet times that 0.333, and you come up with 235.38 cubic feet. Then we divide it by 27. Why 27? We need to convert the feet into yards. There's 27 square feet in a square yard. So again, so that's why we did that. So now we know how many square yards it is. We know how much concrete to order. So that would be 8.71 cubic yards. Alrighty, take your time on this, and let's go through test your knowledge questions in your textbook. And here's your answers. Alrighty, now we're going to get the problems, math problems that you're going to go through. Try to work through that, and we'll discuss it in class together.